Greetings, this is Graham Warren working with you on the Antico Cafe Greco simulation model. And in particular, I want to look at the animation in this clip along with, what we can do with experimentation. So I think we've elaborated the model and we've got some statistics that we're collecting. And then it's this animation piece that I want to just talk about briefly. So I'm going to run it just so you can see how this goes. This is something that I added recently to the simulation. And here we go. And I'm going to speed this up. And I think you can see what's going on here. There are customers coming in here. And then when their beverage is being created, they are joined by a server. And so you can see that there are, let me slow this down maybe a tad. So in every case, you see there's a customer and a client, a customer and a server going through together. So this is the servers are the baristas, obviously. And that's what's happening in this animation. So this is just a visualization of how customers are flowing through the system here, where they come in, they grab a barista, get their coffee made, release the barista, and then sort of head out. Okay, now implementing this thing, what this here is here. Let's just go back and have a look at the setup here. So you can run this in 3D as well. Maybe we should just have a look at that in 3D briefly. So I think I've created something that's flat here. So it's not going to be particularly interesting, but you can zoom in here and observe. Hopefully, I can get this thing to move. No, maybe not. Well, yeah, I hope to do better than this, but apparently my 3D simulation has disappeared. In any case, with a mouse, we could do better and observe these, what is a 2D animation here in 3 dimensions in this 3D window here. All right, so how to set this up? So this first block is actually just a rectangle that I'm coming in from with in the space markup palette. So you can see it's one of these rectangles. And then this here is a path. And this is just simply just a large green dot that isn't a particular markup item or simulation block. So this one here is obviously I've just created some additional lines, but it's this rectangle here. We want to see where that connects to. So this one is node 2, and I believe it's connected to C's server. So when the customer is in that queue, we actually have them represented here as having arrived and waiting, which is exactly what they're doing. They're waiting to grab a server. As soon as they got the server, their coffee starts. And then it's making the coffee connects to this path. And as they go through the service experience, then you're having your barista and your server go through together. Now, the reason why you're seeing both a customer and a server or barista go through here is obviously customers are going through here, but then when that customer seizes the server, it's an agent type, but they're seizing one of the baristas. So let me just go back there. You can see up here at the top, they are grabbing server. So that's why they go through together. There is the customer, but then they've grabbed the barista and they're headed through together. And then at the end here, the server or the barista is released, and then the customer goes on. Okay, so that's how we've created this. So the red here is just lines that I've created with the presentation. palette here, panel. This is just a key. This is text again. You know, this text, these text descriptions are just freestanding text. They're not connected to the simulation anyway. The only connections really are this rectangular block. It's connected to the waiting, to the queue here, and then the path is connected to making coffee. All right, so that's the animation, and hopefully, you know, animations will appeal to, perhaps some folks in your in your decision-making group that may need a little bit, more visualization than what you're seeing in the model itself. Just makes it a little more transparent. So we just have that option. Now I want to talk about one more thing here, and that is this compare experiments. So when I go into this, we've got this experiment option. We can compare runs. So let's just have a look and see what it does. Enables you to interactively input different parameter values and run the model multiple times. Okay, so I'm going to run the compare. Now let's go back to our program here. And then for this, I've got this compare runs. And you can see essentially what's going to go on here. I'm going to be able to plug in things like mean service time, arrival rate, standard deviation, number of servers. So these are relevant questions, as you do what if analysis, scenario analysis. We can change them here in the, let's see, simulation main, I guess. So we can change them when we do the original simulation. We can also do this experimental run thing. So I want to run this one for you. So this is ACG compare runs, and just see how this goes. Okay. So I don't remember what the numbers are, but it just says something like, well, let's go back and at least, so 65, 45, 105, 10, and 3 was the original setup. 65, 45, 105, 10, and 3, right? And 3. And so this then allows us to go ahead and run it. Okay, so what this does is it completes an entire run. These runs have specified length when you set up this compare runs experiment. I don't recall how long that is, but we go to simulation main. Perhaps I think we can see what my cutoff is. I'm using random seeds here, and I'm running this out to 10,000, I guess, minutes. So that's what's being simulated there. Now I could go ahead and run this again. It's identical, but I could also then do a side-by-side, what happens if I change this standard deviation from 10 up to 100 where I don't have trained baristas, let's say. Can run that now. You're expecting the time to go up. Maybe I have to hit that. Yes, there I have to go. And you can see a massive increase mean time in the system. The utilization actually remains the same because variance doesn't impact the variance of the service time distribution, the variance of the interarrival time distribution do not affect utilization. Key insight. Okay, so I think what we're not doing here is using something like optimization where I could, but the ACG case requires experimentation with a number of options. Changing the standard deviation, it'd be 0 for an automated setup, 10 if you have trained baristas, 100 if you have untrained baristas. You may experiment with a number of baristas. That's certainly one possibility, but it's just one of the possible changes that you have to consider. And it's just that it's, I've chosen not to set this up as an experiment, but rather just a compare runs experiment. I hope you enjoyed this one.